Okay. Today we will be doing about the ATS or the PMO theory. ATS, as the name indicates, ATS is aromatic transition state theory, or PMO, perturbational molecular orbital theory. Okay. Now this theory was proposed by the scientists Zimmerman and Dewar. According to this theory, the transition states play an important role in explaining whether the pericyclic reaction is possible under thermal or photochemical conditions. Okay, now we all know pericyclic reactions are concerted reactions. When we say that they are concerted reactions, it means they are single step reactions. All single step reactions involve transition state. So this transition state is important for the aromatic transition state theory or the PMO theory. Now, when we are going to do with the transition states, according to this theory, we have two types of transition states. What are the two types of transition states are? We have Mobius transition state and we have Huckel transition state. Now, what is the basis of dividing this transition state is the presence of node. Now, what is a node? Now, node is a possibility when a bonding interaction takes place, you have zero node. When an anti-bonding interaction takes place, that means when the opposite signs are going to interact, when anti-bonding interaction takes place, then it is presence of one node. Suppose I have two anti-bonding interactions, then I have two nodes. If I have three anti-bonding interactions, then I have three nodes. So depending upon the number of anti-bonding interactions, I will be getting the number of nodes. If I don't have any anti-bonding interactions, then it indicates the presence of zero nodes. Now, based upon the type of the nodes, you are going to have Mobius and Huckel transition state. Now, in turn, both this Mobius and the Huckel transition state are further classified. Now, I will be writing the classification here. Transition state. Based upon the number of nodes. Now, if I have odd number of nodes, you must be knowing what is an odd number. Okay, 1, 3, 5, 7, all these are the odd numbers. Based upon if I have odd number of nodes, then it belongs to a Mobius transition state. Okay, if I have 0 or even number of nodes, then it belongs to a Huckel transition state. Now, both the Mobius and the Huckel transition state again can be classified into two categories. Both of them. We have a 4n pi system and we have a 4n plus 2 pi system. Similarly, Huckel transition state again can be classified into two types. We have a 4n pi system and we have 4n plus 2 pi system. Okay. Now, under the Mobius transition state, a 4n pi system is considered to be an aromatic transition state, whereas a 4n plus 2 pi system is considered to be anti-aromatic transition state. Similarly, when we are going to take the Huckel transition state, 4n pi system is anti-aromatic. Now we know the Huckel's rule, 4n plus 2 pi system. Okay, Huckel's rule, any system which is obeying the Huckel's rule or has a 4n plus 2 pi electrons is considered to be aromatic. The same basis we are going to put here. 4n plus 2 pi system, so this is the aromatic transition state. Okay, so under the Mobius transition state, a 4n pi system is an aromatic transition state. A 4n plus 2 pi system is an anti-aromatic transition. Similarly, under the Huckel transition state, a 4n plus 2 pi system is anti-aromatic transition state. 4n plus 2 pi is aromatic. Now, why this aromatic and why this anti-aromatic, I will tell you. All aromatic transition states, please pay attention, all aromatic transition states are thermally allowed, whereas all anti-aromatic transition states, they are considered to be photochemically allowed. So whenever you are having a 4n pi aromatic system under a Mobius transition state, then it is thermally allowed. Suppose I have a 4n pi system under the Huckel transition state, since it is aromatic, anti-aromatic, it is photochemically allowed. Now we are going to apply these aromatic, anti-aromatic systems for each of the pericyclic reactions what we have studied, whether it is electrocyclisations, cycloadditions, or sigmatopic reactions. Now, we'll start with the first one, that is electrocyclisation. You know, electrocyclisations are reversible reactions. Electrocyclisations are reversible reactions, can take place in both involve both con and this mode of rotation. Okay, and at the expense of one pi bond, one new sigma bond is said to be formed. Take a 4n pi system. For a 4n pi system, 1,3-butadiene, it is being converted to cyclobutene. This is the basic reaction for electrocyclisation. Now, whether I'm going to do it by a con mode of rotation or by a dis mode of rotation, I will be getting the product. Now, for the first one, and one more thing, whenever we are doing with these ATS theory, we are not going to consider any of the HOMO or the LUMO. We are going to go with the basic set of the molecular orbitals. So, an important thing to be considered is basic set of molecular orbitals are considered. Now, what is the basic set of the molecular orbitals which are said to be considered is psi 1. Okay. Now, when I'm going to take the psi 1 does not have any node. Okay. I'm going to draw the psi 1 orbital plus, plus, minus, minus. Right? Now, We'll go with the con mode of rotation. Rotate both of them in a clockwise direction. If you're going to rotate both of them in a clockwise direction, p orbitals will be lying horizontally, the termini p orbitals. Negative is outside, positive is inside. Again, negative is outside, positive is inside. Now, what type of signs are going to interact? As you can see, it is the opposite sign. I am getting one node. So since I'm getting one node, it is an odd number. So in the transition state, I'm getting an odd node. It belongs to a Mobius transition state. Okay. Under the Mobius transition state, a 4n pi system is considered to be aromatic. Why aromatic? Since it is a 4n pi system. Now, I have told you all aromatic transition states are thermally allowed. Since it is a Mobius aromatic transition state, this reaction is considered to be thermally allowed reaction. Okay, are you getting my point? So, con mode of rotation, we are getting one node which is an odd number, a Mobius transition state because it is odd node. Since it belongs to a 4n pi system, it is aromatic and all aromatic transition states are said to be thermally allowed. Now, I'm going to take the same one, the con mode of rotation in an anti-clockwise direction. Con mode of rotation in anti-clockwise direction. So when I'm going to take it in an anti-clockwise direction, again the termini p orbital will be lying in a horizontal position, positive inside, negative outside, negative inside, positive outside. Again, I get one node. So this one node, because it is one node, it's an odd number, belongs to the Mobius transition state. It's a 4n pi system. Hence, it is an aromatic one. All aromatic transition states are thermally allowed. So this one is for the con mode of rotation. Now we'll take it for the dis mode of rotation. Again, we need to consider the basic set. Basic set is psi1. I'm drawing the 4 molecular orbitals. Psi1 does not have any node. Okay. Now, do the dis mode of rotation. When you're doing a dis mode of rotation, rotate one of the molecular orbital in a clockwise direction and the other one in an anti-clockwise direction. Okay. The termini p orbitals will be lying in a horizontal position in the transition state. Okay. Now, one is in a clockwise direction, so negative, positive. The other one is in an anti-clockwise direction, negative, positive. I am getting a bonding interaction here. So can I say it as a zero node? So this is considered to be a zero node. Zero node is considered to be an even number of nodes in the transition state. Hence, it is a Huckel transition state. Since it is a Huckel's transition state, we have to check for what pi system it is. It is a 4n pi system. A 4n pi system under the Huckel transition state is anti-aromatic. Since it is a 4n pi system, it is anti-aromatic. So if it is anti-aromatic, we know that all anti-aromatic transition states are photochemically allowed. Okay. Now, I'm going to do the same dis mode of rotation, but one of them I'm going to take it in a anti-clockwise and the other one in a clockwise direction. Again, the termini p orbitals will be lying in the horizontal position. Okay. Now, when they are in the horizontal position, positive inside, negative outside, positive inside, negative. Again, it's a bonding interaction. So bonding interaction, zero nodes or an even number of nodes. It is a Huckel transition state. It is a 4 and 5 system. Hence, it is anti-aromatic. And so all anti-aromatic transition states are photochemically allowed. Now, according to the FMO theory, if you all have studied, you must be knowing in a 4 and 5 system, Kohn mode of rotation is thermally allowed, whereas this mode of rotation is photochemically allowed. This is again proven by the ATS theory or the PMO theory. Now we are going to make use of the same theory, that is the ATS theory, for a 4n plus 2 pi system. Okay, what is a 4n plus 2 pi system under electrocyclization is conversion of 135 hexatriene to cyclohexadiene. Okay, so under the electrocyclization, we are going to go for the 4n plus 2 pi system. 4n plus 2 pi system. Now, under the 4n plus 2 pi system, again consider the basic set of molecular orbitals. That is nothing but your psi1. Okay. So, you're going to consider the basic set that is a psi1 molecular orbital. Now, I'm going to take this is your molecule 135 hexatriene undergoes electrocyclization to give you cyclohexene at the expense of one pi bond. One new sigma bond is formed. Okay, this can again take place by Kohn or this mode of rotation. Now, since I have taken a basic set, I am drawing the molecular orbital as it is. Okay, these are the molecular orbitals. Because it is a psi1 function, I don't have any nodes. So, all of them will be having the same sign. Okay, so Kohn mode of rotation. Now we know Kohn mode of rotation, both the termini p orbitals have to be rotated in the same direction, whether it is a clockwise or an anti-clockwise direction. Rotate them in, both of them in the clockwise direction. In the transition state, you find the termini p orbitals lying in a horizontal position. Now when they are lying in the horizontal position, negative inside, positive outside, positive outside, inside, sorry, and negative is outside. Now here you are going to get one node, right? It's an anti-bonding. Since it's an anti-bonding interaction, I'm getting one node. So when you're getting one node, is it an odd number? Yes. Since it's an odd number of nodes, I expect this transition state to be a Mobius transition state. Okay. So if it is a Mobius transition state, what pi system does it belong to? It belongs to a 4n plus 2 pi system. Since it is a 4n plus 2 pi system, under the Mobius transition state, a 4n plus 2 pi system is considered to be anti-aromatic. Now, since it is anti-aromatic, all anti-aromatic transition states are photochemically allowed. Okay, now the same thing do for the Kohn mode of rotation in the anti-clockwise direction. Both of them are rotating in the anti-clockwise direction. Again, in your transition state, I have the p orbitals lying in the horizontal position, positive inside, negative outside, negative inside, positive outside. Again, I have one node. Odd number of nodes, so it is a Mobius transition state. Since it is a Mobius transition state and a 4n plus 2 pi system, it is anti-aromatic. All anti-aromatic transition states are photochemically allowed. So for a 4n pi plus 2 pi system, Corn mode of rotation is said to be photochemically allowed. Now we will take it for the dis mode of rotation. Okay, since it is a basic set, I'm going to put the psi orbitals as it is, and I'm going to do the dis mode of rotation. For this molecule, go for the dis mode of rotation. One of the termini p orbital rotate in a clockwise direction, the other rotates in an anti-clockwise direction. Okay, in the transition state, the termini p orbitals are lying in the horizontal position. Now, negative inside, positive outside. Again, anti-clockwise, negative inside, positive outside. You have a bonding interaction. So if it's a bonding interaction, I told you, you will be having 0 nodes. Whenever you have a 0 or even number of nodes, the transition state can be classified under Huckel transition state. Correct? Okay. Since it is a Huckel transition state, it belongs to a 4n plus 2 pi system. So I will say it is a Huckel aromatic transition state. Because it is aromatic transition state, it is said to be thermally allowed. Okay. Check for the same dis mode of rotation. Both of them, one of them is in an anti-clockwise, other is in a clockwise direction. You have the termini p orbitals residing in, lying in a horizontal position. Now, when you all are having it in a horizontal position, positive inside, negative outside, it's a bonding interaction again. Since it's a bonding interaction, you have a 0 node. Because it has 0 node, it is a Huckel transition state. As it is a 4n plus 2 pi system, it is an aromatic transition state. All aromatic transition states are said to be thermally allowed. Now, we are going to write this as selection rules under the electrons. So now we are done with the pericyclic reactions for the electrocyclization. Now, when you are going to write the selection rules, when you're writing the selection rules, please remember that's the easy way to remember whether the condition is said to be possible, under what condition it is said to be possible. Always remember con and dis mode of rotations are for electrocyclization. Whereas for the cycloadditions and sigmatropic reactions, you have a supra and antarafacial addition. Now, coming to your selection rules. Under the selection rules, serial number, pi system, then you write a number of nodes, transition state, then mode of rotation, allowed, you can write it as forbidden also, because one, if it is said to be allowed, the other method is obviously not allowed, that is said to be forbidden. If it is allowed thermally, photochemically, it is forbidden. So since you already know about it, and we have done it only for the allowed interactions, I'm just writing it as allowed in the selection rule. So serial number 1. Now 4n pi system. Under the electrocyclization, 4n pi system will be 1,3-butadiene. Please don't ever forget what moieties or what molecules you are taking under the 4n pi system. Number of nodes you have got. How many nodes? You have got 1 node. That indicates it is an odd node. Okay. transition state, it is a Mobius aromatic transition state. And what mode of rotation was it? It was a Kahn mode of rotation. So it is said to be thermally allowed. Again, for the this mode of rotation, what you have taken, this mode of rotation, you have got zero nodes. Since it is a zero node, it is a Huckel transition state and it is a 4n5 system. So it is Huckel anti-aromatic transition state. Since it is a Huckel anti-aromatic, it is said to be photochemically allowed. Now take for the second one, 4n plus 2 pi system. 4n plus 2 pi system is 135 hexatriene. So for the Kahn mode of rotation, again you have one, that is an odd number of nodes. Because it is a odd number of nodes, it's a Mobius transition state. 4n plus 2 pi system, hence anti-aromatic. All anti-aromatic transition states are photochemically allowed. Zero nodes or even number of nodes for this mode of rotation. So I have it as a Huckel transition state. Because it is a 4n plus 2 pi system, it is aromatic. All aromatic transition states are thermally allowed. Okay. So this is the application of the ATS or the PMO theory in the case of the electrocyclization. Now, coming to the cycloaddition. Now, we are going to do the same process for the cycloaddition for a 4n5 system and a 4n plus 2 pi system. Please pay attention. Now, whether we are going to take it for the any of the type of reactions, whether it is a electrocyclization or cycloaddition or the sigmatropic reaction, ATS theory always involves the basic set of the molecular orbitals, that is psi1. So for all the molecules, you need to consider only the psi1. Without psi1, does not have any nodes. Okay. Now coming to cycloaddition. Under the cycloaddition, we are going to do with the 4n5 system. Now we know 4n5 system under the cycloaddition is nothing but 2 pi plus 2 pi cycloaddition. So when we are talking about 2 pi plus 2 pi cycloaddition, we know that this 2 pi plus 2 pi cycloaddition can take place in 4 types of interactions. We have supra-supra, supra-andara, andara-supra, and andara-andara type of interaction. So all these 4 interactions we are going to see. And for each of the pi system, again, we need to consider the basic set. So 2 ethylene molecules, 2 pi plus 2 pi give rise to your cyclobutane. Okay. First method of interaction, supra-supra interaction. Take the basic set psi1. When you are using a psi1 interaction, okay, positive, 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 negative, negative. Supra-supra interactions, I am having zero nodes. Both of them are giving a bonding interaction. So I am going to get for the cyclobutane, supra-supra interaction, zero nodes because it is forming a bonding interactions, zero node because it is zero node, I have even number of nodes. Since it is even number, it belongs to a Huckel transition state. Okay, it is a 4n5 system, anti-aromatic, Since it is anti-aromatic, it has to be photochemically. So for a 4n5 system, that is two ethene molecules, when they are going to combine to give a cyclobutane, supra-supra interactions are said to be photochemically allowed. Next, the second method, supra-entara. Now, again take your basic set. Okay, so when you're going to take your basic set, molecular orbitals don't have any node. Okay, now supra-antara, that means your second reacting partner has to combine in an antara fashion. Supra-antara. So this is giving rise to one node. Please remember, whenever I'm putting a node, whenever I'm encountering a node, I'm putting a double hash. Okay, so this is going to give you your cyclobutane. Okay, now I'm having one node is getting existed, so it is odd number of nodes. When I'm having odd nodes, it is a Mobius transition state, right? So if it is a Mobius transition state, since it is a 4n5 system, it is a aromatic transition state. All aromatic transition states are considered to be thermally allowed. Okay, now the same thing we are going to do with the antara supra and antara antara interaction. Supra supra, zero nodes, Huckel transition state. Huckel transition state, because it is a 4n5 system, it's anti-aromatic. All anti-aromatic transition states are photochemically allowed. For a supra-antara interaction, I have got one node. Since it's an odd number of nodes, it belongs to a Mobius transition state. If it is a Mobius transition state, the molecule belongs to 4n5 system, it is a aromatic transition state. All aromatic transition states are thermally allowed. Okay, now we will move to the next type of the interaction, that is antara supra and antara antara interaction. Third one, antara supra. Again, take the basic set, psi1 function without any nodes. First partner is reacting in an antara manner and the second reacting partner is reacting in a suprafacial. Antara supra. I have a presence of one node. So I'm going to get a cyclobutane, but this cyclobutane has a presence of one node. Because it is one node, it's an odd number. Odd number of nodes in the transition state, it is a Mobius transition state. As the molecule belongs to a 4n5 system, it is an aromatic transition state. All aromatic transition states are thermally allowed. So, antara suprafacial interaction in the case of the 4n5 system is thermally allowed. Now, we'll take the next type of interaction, that is the antara-antara interaction. In this antara-antara interaction, again take the same basic set of the psi functions. The psi functions should be without any nodes. Both of them are going to react in an antara. Both the reacting partners, opposite side of the lobes, are going to interact. Right? With respect to the first reacting partner, it is an antara-facial addition. With respect to the second reacting partner, it's an antara-facial addition. So please remember. Now, because it is an antara, I'm getting a bonding interaction. So can I say I have zero nodes? Since I have 0 nodes, it is even number of nodes. As they are even number of nodes, it belongs to a Huckel transition state. Molecule belongs to a 4n5 system, so it is an anti-aromatic transition state. As it is an anti-aromatic transition state, it is considered to be photochemically allowed. So for a 4n5 system, supra and antara are photochemically allowed, whereas supra and antara suprafacial additions are said to be thermally allowed. You can verify this whether it is correct according to the FMO theory. Okay, now we will come to the next system, next molecule, next pi system under cycloaddition, that is 4n plus 2 pi system. 4n plus 2 pi system, it is the interaction between a diene and a dienophile to give you an adduct. So 4n plus 2 pi system, it is 4 pi plus 2 pi cycloaddition. Again, I am going to do with supra antara facial addition, antara supra, and antara addition. Okay, now diene reacts with a dienophile to give rise to an adduct at the expense of a pi bond in each of the reacting partner. 2 new sigma bonds will be formed. Right, these 2 are the new sigma bonds. I'm going to take the same basic set. So the first one, suprafacial addition. For the diene as well as the dienophile, we are going to take the basic set, that is the psi function. Positive, 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 negative, positive. Right? Suprafacial addition. Both of them are giving a bonding interaction. Since both of them are giving a bonding interaction, it has to be a 0 node. Okay, so it is giving a 0 nodes, even number of nodes. Since it is even, the transition state is a Huckel transition state. As the molecules belong to the 4n plus 2 pi system, it is an aromatic transition state because it is a 4n plus 2 pi system. All aromatic transition states are thermally allowed. Now, coming to the second one, supra-enterafacial addition. Again, for your diene and your dienophile, take the basic set of the molecular orbitals. The basic set of the molecular orbitals do not have any node in them. You are checking for the nodes only in the transition state. Now, the first reacting partner is going to add suprafacially, whereas the second reacting partner is going to add anterafacially. So this is a suprafacial addition. This is your anterafacial addition with respect to the second reacting partner. Okay. Now, when I am adding a suprafacial, whenever it is adding suprafacially, I am getting one node. Presence of one node. Since I am getting one node, it is an odd number. Transition state can be a Mobius transition state. As the molecule belongs to a 4n plus 2 pi system, it is anti-aromatic transition state. All anti-aromatic transition states are photochemically allowed. For a suprafacial addition, supra-supra interaction, you have zero nodes, you get a Huckel transition state since it's an even number. As the molecules belong to a 4n plus 2 pi system, it's an aromatic transition state. All aromatic transition states are thermally allowed. When we are taking it for the supra anterafacial addition, the first reacting partner, that is your diene, is going to interact suprafacially, whereas your dienophile is going to interact anterafacial. Now, in this interaction, in the transition state, I'm getting one node, that is an odd number of nodes. Because I am having an odd number of nodes, I'm getting a Mobius transition state. As the molecule belongs to a 4n plus 2 pi system, it's an anti-aromatic transition state. All anti-aromatic transition states are photochemically allowed. We'll go to the next type of interaction, that is a antara-supra and antara-antara interaction. Please don't change the basic set of the molecule. Take the same basic set, antara-supra. That means the diene is going to interact anterafacially, whereas the dienophile is going to interact suprafacially. Plus, minus. Anterafacial addition. This is a suprafacial addition. I'm getting one node. So in the transition state, a presence of one node, again, it's an odd number of nodes. Odd number of nodes in the transition state, we expect the molecule to be undergoing a Mobius transition state. As the molecules belong to the 4n plus 2 pi system, it is an anti-aromatic Mobius transition state. All anti-aromatic transition states are photochemically allowed. Now, go for the last type of interaction, that is antara-antara interaction. Again, for your diene, take the basic set, that is psi1 function. Dienophile, again the basic set. Okay, both the molecules are going to interact anterafacially. That means both the reacting partners, opposite lobes are going to interact. Now, whenever I have opposite lobes interacting, I'm getting a bonding interaction because it's a like charges. Same here, I'm getting a bonding interaction. Since I'm getting a bonding interaction, I will be getting zero nodes in the transition state. So since it is a zero node, even number of nodes, the transition state can be classified as a Huckel transition state. As the molecule belongs to a 4n plus 2 pi system, it is an aromatic Huckel transition state. All aromatic transition states are said to be thermally allowed. So for a 4n plus 2 pi system, supra-supra and antara-antara facial interactions are thermally allowed, whereas supra-antara and antara-suprafacial additions are said to be photochemically allowed. Now, this will be in accordance with your FMO theory. We are going to write the selection rules for the cycloaddition. I hope you all have understood the cycloaddition. Now, please make a note of the selection rules. The selection rules are nothing, will be enabling you to write the interactions correctly when a question is asked for the essay type. Okay. Now, selection rules. Serial number, pi system, type of interaction, number of nodes, transition state allowed. First one, 4n pi system. This is nothing but 2 pi plus 2 pi cycloaddition. Under the 2 pi plus 2 pi cycloaddition, supra interactions, they have 0 nodes. Transition state is even. Transition state is a Huckel 4n pi system, so anti-aromatic. All anti-aromatic transition states are photochemically allowed. Similarly, supra entera, I have one node that is odd node. It's a Mobius aromatic transition state, thermally allowed. Entera supra, one node, odd number of nodes. Again, it is a Mobius aromatic transition state. This is again thermally allowed. Entera, I get 0 nodes, which is even number. Huckel anti-aromatic because it belongs to a 4n pi system, hence photochemically allowed. Next, second one, 4n plus 2 pi system. 4 pi plus 2 pi cycloaddition. Again, take supra type of interaction. You get 0 nodes. It's an even number. Belongs to a Huckel aromatic transition state. Hence, it is thermally allowed. Supra entera, one node, odd number, belongs to a Mobius anti-aromatic, hence photochemically allowed. Entera supra, one node, odd number of nodes, so it is Mobius anti-aromatic, photochemically allowed. Last one, entera facial addition. I have 0 nodes, even transition state, so it is a Huckel aromatic transition state, thermally allowed. Now, this selection rule is a tip for you to understand, is a tip for you to have an easy idea about whether it is said the reaction is said to be possible under the photochemical condition or the thermal condition. In the next video, I will be telling about the sigmatropic reactions and we'll be applying the ATS or the TMO theory to the sigmatropic reaction. I hope you all have understood about this ATS theory. Thank you.